Hello friends, welcome back to our channel. So in today's video, we will be looking at how to run weather research and forecasting model on your personal laptop on the Ubuntu operating system. So in previous video, if you have followed, we have discussed how to set up your domain, how to download various data sets. For example, we have discussed how to download the geographical data set, which the geographical data set is necessary for for complete real data case simulations, and we have also looked at how to download the WRF initial condition from various different uh, sources. For example, there are from NSEP, we have final reanalysis data, which is FNL data. From the ECMWF, we have various different data sets, for instance, ERA5, ERA interim, and also ECMWF operational forecast. So, keeping those things in mind, we have selected one particular data set, which is FNL. We have downloaded it, and we have used that for our simulation purposes. So first, we did uh, we set up, we specified the number of domain which we want to run the model, and we go on to this describing the time interval for our simulation, which were from 1st of July 2024 to 2nd of July 2024. So this were the name list in which we specified various different parameters which were important for the execution of various programs in the WPS. So in this share, we have described the WRF core, which is the advanced research WRF, and we have specified maximum domain 1, start date uh, of 1st of July, and then end date of 2nd July. And then we have described the interval, which is there. We are using 6 hourly data. So we have specified it to uh, 21,600 seconds. And we have included this, we have specified in IO from GeoGrid, which is 2, which is corresponding to the NetCDF output. And then we go on to adding some directories for the writing up of the output of GeoGrid program. So in this directory, we have stored all the output from the GeoGrid program. Here we have described the various domain specifications. So as I said in the last video, that we are using Mercator projection here just for an example. Uh, what type of projection you may need to use will be determined by the location where you want to run your model. For instance, if you are planning to run your model in the polar region, let me show you first. I think the verbal explanation will not be of much value. Let's go to the WRF documentation. WRF documentation. Okay, so we will discuss in the documentation. We have various uh, type of preprocessor. WI preprocessing system. You just go to here, and here we will be having installing, running, and creating nested domain in WRF. So look, okay. So what is this showing? So let's go one by one. So let's take a look on this architecture as to how the WPS pre-processing system works. So we have external data sources, which is the static geographical data, which we have downloaded, uh, uh, and uh, and then we have the gridded data from either from GFS, from M, or from ECMWF, from Vera5, or from any other suitable agency. So this static data is used by the GeoGrid program. Okay. And this gridded data, which is the 3D atmospheric field, uh, has been used by Ungrave. Okay, so Ungrave makes these 3D atmospheric field into the intermediate files. Here we have the location or the coordinates of grid from the geogrid program, and namelist.wps specifies what type of domains should be made, and and from which duration or from which date to which date the model should be running. So combining geogrid and ungrid through the namelist WPS, we were able to run the medgrid program. So medgrid takes input from geogrid, it takes input from ungrid, and reads the namelist.wps to generate met files. Okay, these are the meteorological grid files, and then these mets file will be used by the real.exe program. Okay, so in the WRF there are two programs. One is real.exe, the second one is the wrf.exe. The real.exe actually used for the for creating the boundary condition as well as initial condition. So the met grid are not really initial conditions. They are the 3D atmospheric field uh, uh, suitable for the WRF input file, and in the resolution which you have specified in your WP namelist or WPS. Okay. So what type, how much resolution you want horizontal, you be specified in the WRF namelist or WPS, and that that input will be used to create met files by the metgrid.exe. And then once we have met files after executing the metgrid program, these met files will then be used by the real.exe program to create initial and boundary condition. Okay. Okay. So there are various things. So I don't want to get right now into the details of it. So I am just giving a top level introduction to running the model. So there are various programs. So you can read various details of these programs from this documentation. Okay, so let's go to the various projections. So we have several projections. So here are projections. So they have not. So yeah, I guess we cannot zoom out. Yeah, I think PDF will be much more valuable than this. Okay, let's wait for it to come. So yeah, so we had discussed how to make the simulation domain. So we have used a Mercator projection because we were interested in running the model over the equatorial region. If you are interested in running the model for the polar region, you must use a polar stereographic projection. And if you are planning to run for mid latitude, you can choose the uh, Lambert conformal projection, and if you for Twitter, you can use Mercator or let alone grid projection. But if you are planning to run globally, then it is recommended to use let alone grid projection or let alone projection rather. Okay. So yeah, so for different type of projection, you will need to specify different type of variables. Okay. So you need to choose which type of projection you want to use. Okay, and accordingly you need to specify these parameters as per the projection you are using. Now what we did, we have just specified the geographical data path for our geographical file. It has to be accurate, otherwise model won't, the execution will fail. And then we have opt grid table. So these are the geogrid tables path. So it has to be WPS geogrid. And then are all other are just uh, trivial things. So no need, you even if you do not specify these things, your run will work. You are not going to face any issues. Then we have specified the output format, that is the WPS and prefix file. Okay, so you don't need to change these things for now, but for advanced user, you may need to change if you use different data set. Uh, for MatGrid option, we have specified the file flag name, which is coming from this prefix. So it will use this flag here. and output is for NetCD. Output has netcdf file, and the path for output is in tutorial. This path you can specify whichever suits for you, and then opt metgrid table path. So here we have the table metgrid table path here. Okay, so after specifying all these things, what we did, we ran the model. Okay, so we ran to okay, let me close it. Okay. So first we ran the geogrid.exe. So okay, so it would take just few seconds to complete. So in last you will see the successful compilation of geogrid, and at the same time you will also get the okay, let me open it in new window. So let's go to WPS out tutorial test one. Okay, so here this was the outputs location. Okay, so here you can see we have this time is 22:52. This is the 10:52 in the night. So this is the recent file, so which we have created recently. Okay, now what we can do is to uh, run the uh, ungrip program. So what were the steps for running the WPS for ungrip? First, you need to link the various where we have kept the FNL data set. Okay, so let's describe. I think it's just one directory up. So input data. Okay, and so just FNL and then select all at current directory. So we have linked it. Now we have to link the v table. Okay, ln sf ungrave vtable gfs and vtable. Okay, so we have linked this. Once we have linked this, we can run the ungrave program, ungrave.exe. Okay, it will take few seconds to complete. Till then we can see if the documentation is ready or not. Yeah, documentation is ready. So yeah, let's go to uh, the so there are various projects. So we have polar stereographic projects, then we have Lambert conformal projection, which is for that you need to specify true latitude, true longitude too. So where these 2 points will be cutting over the earth, you have to specify this. For polar stereographic, you have to specify only true latitudes. One latitude will be enough because it is on the same circular region, and it will look like this. For Mercator, you need to specify true latitude from where there's the MF factor should be 1, where it is touching the Earth surface. So this is the true latitude. And there are other variables, for example, the reference latitude, reference longitude, and so on and so forth. Okay. And then we have cylindrical equidistant. This is let alone projection. Okay, so yeah, I think these projects are described fairly and fair with described fairly good in this documentation. So you can just go through it and check which projection is best for you. And if you are not very familiar with this, there are other options to do it. So what you can do, look, let me. There is one software. This is called WRF domain wizard. Okay, so WRF domain wizard. Okay, so open Okay, let's use vi. Okay, so what we have to do, we have to run this one, tar this one. Okay, so I have already installed it. You have to just download and run. There is no need to, there is no steps to install it. Okay, so just run it. So it will open the WRF domain wizard. Okay, you have to specify where your WPS is, where your geographic files are, where which is domain you want to specify, and this is, let's use the new domain and just give it to just new test one. Okay, and now you will be in this WRF domain wizard. Okay, now what you can do, so you might be uh, interested in choosing different data. That means, I mean, you might be, you might want to select, for example, I want to select this region. Okay, you can just use a cursor to drag this and expand this square, and what you can do, you choose what type of which projection you want. So there are various projections: let alone regional, let alone global, let alone for non-hydrostatic mesoscale model, polar stereographic, Mercator, Lambert conformal. So I am using Mercator. Okay, so it will specify whatever is necessary for, so you do not have to worry about. So it will specify the standard longitude and true latitude one and true latitude two. So it is not necessary to specify this one, but central point need to be specified. So where you want to keep. Okay, so this is the central point of this. So you just use these variables in your namelist.wps. Okay, similarly, if you change it to the Lambert conformal, you have to specify many other parameters. Similarly for the polar stereographic, you have to specify some other. For regional let lot, similarly for all different things. Okay, so you can update the map and it will show you the actual domain. Okay, then you can also change the horizontal resolution. Then if you change the horizontal resolution, you may need to increase the grid distance. So for example, if you increase the resolution to 10 kilometer resolution, then it will become very small. Okay, so you need to increase then the size of the number of points which can cover this whole domain. Okay, so you have to manually see which number of grids can cover your domain. Okay, so accordingly you can select which are reset grid, and then you can uh, choose which works for you. So first you fix this, then you can tweak all these different parameters for horizontal grid dimension, uh, y and x dimension, and the distance between the grid points. So, and this is the geographical data resolution. So what type of, how much resolution you want to use. So if you use high resolution, it will take a lot of time. If you use low resolution, 10 meter is sufficient. That would be useful for running the test cases. And if you are not really much concerned about the resolution of your input field. So this is the software. This is the one software you can use initially if you are not very familiar with the complexities of these name list options and other things. Okay. Okay. Now let's again go to our WRF. Let's close it. Let's first close it. Okay, clear it up. And then we have already completed the running of ungrip. Now what we have to do, you have to just run the geogrid.exe. Okay. Once geogrid.exe will be completed, you can check the completion of this here. Okay. So it is completed. So success compilation of geogrid program. Now we can just list out our new files. Okay, so we have various different files for the geogrid. Okay, so it has perhaps the overridden. Uh, so I don't know. Let's again try metgrid.exe, met.get.exe. So it is completed. Now let's see. Yeah, so we have new metgrid files here. Okay, we are running it for just 24 hours. We are just creating files for 24 hours. So we have 24 uh, our files. Now what we have to do is to start learning how to run the WRF. Okay, so this is up to WPS. Now the task is to run WRF. So for that, let's go to WRF, build, WRF, then WRF. Okay, then go to run directory. Okay, yeah. So now we are in run directory. So but first thing we have to do, we have to check that all the executables are available or not. Okay. Okay. So all the executables are available and model is ready to run. The first thing we have to do is to open the name list dot input. Okay. So this is, we have to specify several things here. First is the time control, where we will control how for how much duration we want to run the model, for how much time step we want to save the output, whether we want to save it in netcdf or whether we want to save in other format, whether we want to save all the output in one file or in different files. So these, or whether we want a restart or not. All these things can be specified here. Okay. The second one is the domain specification. So how large the domain, that this section has to be very this this section has to be exactly same to that of WPS for some parameters. So for instance, for time step, you can specify up to 6 times your horizontal resolution in kilometers. Okay. So for instance, we are using 50 kilometer here, approximate 50 kilometer. So 50 into 6 is equal to 300. So you cannot exceed 300. If you exceed, there will be instabilities in the model. Try to keep your time step below this threshold. So we are using 180 for safe side. Now you can time these, you don't have to worry about, keep it to default these things. Now maximum domain is 1. East west has to be same, 40-40. The other row is for the second domain, nested domain, which we are not using currently. We are only working for one domain. Then E vertical is the how much vertical level you want. In WPS, we haven't specified any vertical level. We are using 34 level, which were provided by the input data itself. We are not changing anything. Now here we have freedom to run the model with high resolution or resolution, whatever levels we want. So here we are using 38 just randomly. You can use high or low depending upon how much computational resources you are having. And here we are, this is the D stretch factor, DZ stretch. That has to be tweaked so that you are not model not becoming unstable. So you have to somehow tweak if you get the error. If you don't get, that's good. But if you are getting, so you need to adjust it somewhere, either make it higher or lower so that your model gets, uh, so you will be able to run the model. The top requested is the vertical model lid. So this is the top atmospheric level, which has to be specified. So it will be used at top. boundary condition for the simulations. Number of meteorological level 34, which you have to check from the met file. How you will check? You have to uh, go to the okay here, and so let's open one met file. Now NCL file, any of the one file we can open. Okay. So it will specify, it will show you different description of it, but it is not showing right now. Let me uh, write it in the info met.txt. Okay. Now open info.txt. Okay. So here we can get the idea of various parameters in the medgrid files. So dxd by 50 kilometer. Here we all the specification which we have given, all the different parameters. Here we are interested number of soil level. This is 4. Let's go to here. Number of medgrid levels 34. Okay. Number of soil layer 4. So we have to use that same number. If you do use different number, it will throw an error that dimension size are mismatching. Okay, so make sure that you are using exact number which are necessary for the nameless.input. So these are the soil level which are for dxdy we are using 50 kilometer. So grid ID is 1 because we are using only one domain, and if you use two domain here, that is the case of nested simulation, then you have to specify all these things here. So in next video, in this different video, I will cover all these things. And the parent grid ratio only comes into picture when we are using nested domain. And all these parent to grid ratio or IJ start, all these becomes relevant only when we are running model in the nested fashion. Feedback is also the same. And this is the physics section. What is physics section does actually? Here we have to specify what type of, there are several parameterization schemes are available for the in the WRF modeling system framework. So you can choose what suits best for your case. And so there are various parameterization scheme, for instance, microphysical parameterization, cumulus parameterization, radiation, long wave, short wave, planetary boundary layer, surface layer, land surface parameterization, land urban parameterization, and ocean. If you are coupling with the ocean, then you may need some other uh, specification here. So I am using just default corner suit, which will be used which will use the best possible combination of these different schemes. But if you comment this one, if you remove this one, then you have to specify here the numbers. Okay. So for instance, let WRF physics, physics option. Okay. So you will have several different options. So this is the WRF physics option. So for microphysics, for planetary boundary accumulation, so all for all physics option you will have different. For instance, let's microphysics. So for microphysics, you have, if you specify option 1, it means you are using Kessler scheme. If you specify 2, if you are using this scheme. Similarly, if you are using uh, any, for example, 96, here is not 96. Yeah, there are various. So you, according to your case, which suits best for your option, you can use that for your simulation purposes. For example, for cumulus scheme, you can use various options. old can French, grill scheme, new Arakawa scheme, new TDK scheme. So all these options can be specified in this name list option. Now you need to also, you do not have to worry about this one. This is for the data assimilation. If you are doing data assimilation, then you need to add some parameters here. But we are not doing currently, so we are just keeping it blank. Now for the dynamics, you do not have to worry about, just keep it as it is default mode. If you are not very familiar with, or if you are not a advanced user, do not tweak all this. So here I am just showing how to run the model. So we are using just default values. Okay. Here the boundary control option. So here we are a specified boundary option we are using, and specified is true. If it would have been a ideal simulation, then we would have changed this one, but currently we are not changing it. Okay. So this is all about. So make sure that you are using a very clearly, you are specifying everything correctly. Cross check all these entries. There shouldn't be any mismatch. If there are mismatch, it will throw an error and you will be in trouble, because if you miss a 1 comma, uh, you will keep searching for where you have made the mistake. So make sure that everything is perfect. So here you can specify run hours in time. So here is the run hours time. Here we are just want to run for 12 hours, though we have 24 hours boundary conditions, but we are just planning to run for 24 hours, for 12 hours. If you exceed it, you will not be able to find the files. So for example, if you want for 36 hours, if you are planning to run for 36 hours, you have to create the file, migrate file for 36 hours. Then you can use 36 hours. Otherwise, you cannot. Okay, so make sure that all these entries, start days and end date, are same as we have used in the metgrid file. Or it is not necessary to use, it is not necessary to be same, but within the boundary, within the limits of that file, within the limits of metgrid file. So you can choose any of the uh, starting or ending date. Make sure that these files, whichever date you specify here, should be available in the metgrid files. Okay. So here is the interval, which has to be same as your input metadata files, which is the, in our case, it is 6 hour input from file, that is true. Uh, uh, Input from file, that is true. History interval is 60, which is the 60 minute, which is 1 hour. So model will write uh, output in every 6 hourly time step. Okay, so whenever model reaches to the 6 hour integration, 60 a minute integration, it will write the output again in the next 60 minute, it will write again out. Similarly, for every 1 hour, model will write the output. Here the frames per out file, how much frame you want to keep in the one output file. So here I want 1000 frame in output file. One means I am keeping all these files in one. Okay. Restart, we are not, this is not restart run, we are just running it. So it is false. If you are running it, if you are restart running, if you are restarting your simulation, then you have to keep it true. Okay. Then here restart interval is very important. Suppose if you power has gone, or something gone wrong in your simulation and it got terminated in between, then at least you will have restart file to restart the simulation again. You do not have to start your simulation from the beginning. It will save a lot of time. Input output from history, that is all, everything is 2, means all the files which the input and output will be used are the netctf. You can change it to any other format, but it is highly recommended to use netctf format. Here the domains, we have already discussed this. It has to be 40, which we are using. Maximum domain is to be 1, and you do not need to worry about this one for now. Okay, so we have already discussed these things. Now we are all set to run the WRF model. Okay, okay. Let's close it down. And now what we have to do, the first thing we have to do here is to link. Okay, so link where your mat grade, because WRF will be requiring the mat grade files. So whatever we have SF, let's go to the uh, input data and WPS out, WPS out tutorial, and we have the mat grid star and link. Okay, now we will having the link of these. Okay, yeah, so these are the link, recently created link for all the 5 mat grid files. Okay, now once we have linked all this, first we have to run the real. So what this program will do, it will generate us the initial and boundary conditions. So let's execute it. Okay, now check for .exe, and then it is giving some error. Mismatch between lamination input file dimensions. Okay, there is 40 and 60. Okay, so this has to be checked whether it is correct or not, otherwise it will throw an error. Okay, gedit input. What was the file name? Name list input. Okay, so here what mistake I made. Let me go back to here. Let's see gedit memlist.wps. Here the 40 and 60. Okay, so we have to make sure that it is 60. Otherwise it won't run. That you have to be also careful. Okay. Now let's again go to run directory and run.real.exe. Okay. Now tell rsl error. Okay, so it is showing a success compilation of real EM. So we are done. Now we can check whether we have generated the initial file. Okay, so this is the input which is recently created. This is the boundary condition. WRF BDY boundary condition, WRF input is the initial condition. So we now have initial and boundary condition. Now we are all set to run the WRF modeling system. So you can run either in parallel mode or in the serial mode, whatever suits you well. So let's use, so for the parallel mode, you can use MPI run, NP, how much processors you want here, and then wrf.exe. So it will take some time to run the model, and till then we can wait for it to complete. Yeah, so it is, I think, let's check. Tell RSL error. Yeah, so you will see the message success complete WRF. So WRF has been completed. Now let's see the result. The result. Yeah, so we have this one. Okay. So now this one is the recent one. So it was the old one. So this is the recent one. So now what we can do, we can move this one to, because these are the netcdf file, but they have by default they have some strange clock type extension. So we have to make it a proper extension. So we'll just remove this clock, make this .nc. Okay. Yeah. So now let's check uh, if we can plot something from this simulation. Okay. So let's go back. If we have something to plot here, WPS out tutorial. I guess we do not have, and to search where we can find the info data WPS WRF. WRF plotting. Okay, so let's go to WRF plotting. Okay, now open this WRF. Okay, yeah, it is not responding, I guess. Okay, let's open it again. We'll start. Okay. So yeah, so this is the, so here I am using the NCL language. So you have to specify where your file is. So we have specified this is in the WRF run directory, which we have renamed it. And let's plot these. Let's plot the precipitation or U and V and total rain. So let's activate the NCL environment. Okay, let's go to this folder. WRF installation, and here WRF plotting, here plots. So we have recently generated these plots. So in the first time step, we will not have any accumulated precipitation. Now the precipitation is getting to accumulate. Okay? So you can visualize each data set using different softwares. So yeah, this is all about running weather research and forecasting model. And so this was just a simple tutorial. So I had not covered the detailed various complex aspect of it. So as you gradually become an advanced user, you will be able to find out various things by yourself, reading by documentation. But for meantime, if I find time, I will definitely going to upload several different videos on this topic, and I will keep you updated about my future videos. So I hope that this video might be of some value to you. And if you like this video and in any way they might be of any value to you, please do not forget to like and comment your valuable uh, inputs for improvement of these videos, and also share with your friends who might be in need for such kind of videos. Thank you very much for watching, and I will see you in the next